today is the following. Fume ceiling. Equivalent. One. B. Model star will be 2. Here is for H omega 2, F omega 0, and S omega 1, A belonging to UB E is model complete. And is the model companion of theory of PG epsilon delta 0 and PG APG A belongs to B for N for belonging to B and G B generic for B. Okay, so this gives a nice model theoretic formulation of axiom star, which essentially even the model theorists can understand, provided they understand what is the notational ideal and what is the universal universe. Okay. And also it says it gives an even stronger form of maximality for Python sentence than Woodin's theorem, because Woodin's theorem says every type of sentence which is forcible falls in the star model, and here it says every type of sentence which is consistent with the universal and existential fragment of the theory of P is is realized in the star model. Okay. So I have to define these and these, or I can assume everybody knows. So let me know.
Can you define star UB?
Star UB is star, but you ask that every then set universally value in the code is met by the. Okay. So star is saying every set definable in LFR is met, and star UB says the same, but you also have to meet all sets which are universally valid in the code.
Is that strictly strong? Okay. So that's strictly strong in the star.
Yes, because well, it depends also on the axiom of the theory, but typically yes, because that can be universal sets which are not in LFR.
But that's about meeting the set, but you have the other condition. So the power of omega 1.
Yes, that's remain. So the request is that the power set of omega 1 of so what you ask is this LBG.
No, this is bigger. This is bigger than the level power. I mean, this. So this is kind of easier to me. No.
What?
The power set of omega 1 is the kind of UBG. That's what you.
Yes, I mean, an outcome will be that this will be the same as the power set of omega 1 of B.
So you already the star, you have the star. So this is what I mean. If you have star, that's a priori. This part is stronger for star.
Yes, but the other part is weaker. You have to meet and much less than that. I mean, this is almost automatic provided V satisfies Martin's axiom. Because you have almost disjoint coding and every subset of omega 1 is essentially coded by a real. Provided in this model you have, for example, a sequence of one many reals which are almost disjoint. Here you have that every set of every subset of omega 1 is coded by a real modulo this almost disjoint sequence. And here, and this almost disjoint sequence is also here if we is a model of TFC, which okay. And here, if we model Martin's maximum, it says there is a bijection from power set of omega 1 and power set of omega, such that every subset of omega 1 is coded by the real, which has, I mean, so this equality is actually not very strong. It follows from Martin's axiom. Okay. And what about stealing? I can assume everything, or it's fine. Or there are some of you that want a reminder on this.
Yes, I want.
Okay. Stealing. Generic for P belonging to P and H is P generic, G generic for Q belonging to G, then L U P B G embeds elementarily into L U P B G H via the map that sends A intersection A, no, it's actually all UV sets appearing in BG. A, BGH for H, for A belonging to UP VG, and alpha and any injection of the indiscernibles for LUP VG into indiscernibles of LUP VH. Sorry, VG. So what this ceiling says essentially is the theory of this LUB is phrased in a very canonical way, in the sense that the canonical map, which to a universally per set associated natural extension in the generic extension, coupled with any injection of the indiscernible for this structure.
Oh, I see, okay.
Indiscernible of this structure into the indiscernible for this structure is elementary. And what I need in this proof will be just cos theta bigger than Alex 0, but let's say and theta is regular. And I guess, I mean, for the proof I just need this, but then usually this is coupled also with and ADR holds in.
So where do you use the injection or indiscernibles?
Huh?
what is?
I will not use, I will need a weaker version of ceiling. I will need just that the H omega 1 united the universally burst set is elementary into the so I will not use the part of initial neighbor. I just need that this together with the identity on H omega 1 defines an elementary embedding of H omega 1 epsilon into H omega 1 epsilon of the bigger stuff.
Theta regular is for the C or theta regular is formally for the C?
Actually, no. The problem is I will need that if you take, so I will not need theta regular in the proof. I will need that if you take a countable sequence of universal reverse set, they are not cofinal in the weight rank on theta. So actually the proof will need the proof needs every set A containing 2 to the omega definable in H omega 1 H omega 1 union UP epsilon is UP to the definition made in H omega 1 union UP epsilon are invariant across force induction extensions. May provide with parameters. So, and 3 if an n in omega is contained in UB, let's say the product over n of the an is still UB. So you cannot reach theta by countable sequence of universal reverse set by looking at the weight rank of the countable sequence of universal reverse set. Okay. And let me recall, I mean, this piece will follow once we prove this by the theorem of yesterday.
Theorem
Of yesterday, that
Yesterday.
the pi 1 theory is preserved across force and extension. Okay, so, follows since for C pi 2 sentence in above signature we have that C plus plus
So what's the brackets?
huh?
What the brackets?
This part. And T equal theory of B and S omega 1 sorry, this is not exactly correct. Well, no, I think QP, we have that C belongs to the theory of H omega 2 epsilon delta 0 and S A belongs to BP. So if this is model complete, if and only if C plus T, sorry, if and only if, well, this is C is universally conservative over T for all that exist. This is followed by standard properties of the model companion theory and which means that which implies, by the way, that C plus T for all that exist is consistent. Okay, and actually it's Newton only. Okay, so I will eventually come back to this later on. This is purely model theoretic stuff. There is nothing peculiar on this. Okay, and it's just not particularly difficult. It's just using the model theory of basic model facts about model theoretic facts about model companions. Okay, and what happens then that if you have a Python sentence, then it holds here. It means that it is consistent with the universal and existential fragment of the theory of V in this signature, but this theory is invariant across forcing extension because of the theorem of the other day. So it means that the universal and existential fragment of these theories is always the same, independently from the forcing chosen. Okay. Huh? Yes, sure. So this part will be, sorry, this is not exactly correct. Well, and actually, sorry, there is a last, there are two B. We have, and this way I use the equivalent, sorry, apologies. So the following equivalent, yes, over, yes, and then you are right, over CFC plus class many Woodin plus C.
Question, so is minus omega 1 here additional thing we can assume, or is it?
Yes, you are right. That if you plus actually don't think that from this we will be able. No, I think we just have this. So I mean, from this assumption, I think we will only. So the question is, do we need the precipitousness? I think we need it. Apologies. Plus, yes, plus NS is precipitous.
Are all these mutually consistent?
Huh?
Are they consistent?
Yeah, I mean, the point is, ceiling, once you make it true, it's forever true. I mean, this statement is saying that once you have made the ceiling true, you will maintain it across all further generic extension. So once this is done, it's okay. If you start with plus many Woodin, you can make an essence precipitous true at your will and kill. saturated in LUBG. But what happens outside? Yeah, it's actually, no, because of this equality, it will follow in general. Yes, so actually you don't need this cluster of sanctions. See, what happens is, if you have this equality, and star implies that in LUBG, NS is saturated, which means that the anti-chains have only size Aleph1, and but those are no. So you cannot have.
But it's still inconsistent with supercomputer.
Huh?
It's still inconsistent with supercomputer.
Yeah, you get it from class.
If you have class, okay.
Yes, you're right. If I just have one super compact, I will. When I kill the super compact, then I will be in trouble to prove this equivalence. But if I have plus many super compact, then the equivalence will hold always.
And you can always force sealing.
Hmm?
You can force sealing.
Sealing so you start from a model with class many super compact. You burn one super compact and you make true sealing in whatever forcing extension of this first step, and you still have class many super compact. Then you have to play a bit to get an S precipitous, and you maintain. I mean, you have done it with the forcing, so you maintain that there are class many super compact and that the sealing is true. Okay. So the question is whether I mean, this is the only one that is not outward true in any forcing extension of a model of sealing with large cardinals. So this can be true and false and flip the true. Okay. So the proof of this theorem amounts to show that every universal formula is provably equivalent to an existential formula modulo this theory.
Sir, if you forget about NS omega 1 and 2, if you forget about NS omega 1 and 2, if you forget about the assumption of NS precipitous, does it still hold or?
So what will happen if we drop the assumption NS is precipitous? I guess we will have one equivalence, but not the other. One implication, but not the other. Let's see. I think we will have this implication. Okay? Because the model completeness will say also that whatever Phi2 sentence you can make true by forcing is true in the star model. Because this form of consistency is stronger than forcibility of the Phi2 sentence. And so if you have this is model complete, this will follow just by purely model theoretic fact. So you will get that every Phi2 sentence which is true in some forcing extension is forcible, and this should be an equivalent formulation of star. Right? But on the other hand, if you want to go from here to here, essentially what you need is that you have that V models this stuff, and is an iterable condition in a generic extension collapsing everything relevant to countable. So, and this will need that V model that an S is precipitous. So actually, well, maybe not even, because you can maybe this is not relevant. I mean, because you can establish an S is precipitous in a forcing extension by a station that preserving forcing, which means that the forcing extension is an iterable condition, and that should be sufficient for the proof. Okay. So essentially, I think this can be relaxed. I mean, from the proof it will be clear. Plaza may be relaxed 2. NS is precipitous can be forced by SSP force. In which case, those assumptions are sufficient because with class many supercompacts, you can always force NS precipitous by the station. Actually, with class many Putin. Okay. Can I erase? So let me define star. So there are no ambiguity on what I will try to prove. If a contained in omega 1 is such that error a omega 1 b, then GA equals 10 belongs to P max. Sorry. A belonging to P max. So what happens is I'm dropping the reference to the ideal because I assume that the ideal is always the non-stationary ideal. This is a non an assumption that we can do in this setup because you start from a condition which has a bad ideal, which is the non-stationary ideal, which is precipitous, and you refine it to a condition where the ideal is now the precipitous, the non-stationary ideal, and this precipitous. M belongs to P max, such that there exists J alpha beta, alpha less beta, beta less beta omega t, iteration of M such that the J0 omega 1 of A is equal to A. Is LUB generic for P max? So this is a bit stronger. Typically, for example, if you look at what Asper and Schindler prove, they prove if a set is universally buried in the code, if a dead set of P max is universally buried in the code, then this filter meets that set. But if we assume ceiling, every set of reals definable in this model is universally buried in the code. So this is a bit stronger. The usual assumption would say if D is a universally buried set in the codes which is dense in P max, this filter meets that dense set. And power set of omega 1 of N UP GA is equal to power set of omega 1 of well, this is yeah.
So usually we get that this is L of R generic.
Yes,
Now you
so
can-
I'm interacting. Yes. So for example, what is the problem with LFR? The problem with LFR is the cos theta. The LFR has a theta which has countable copinality. So you can have a family of countably many sets which are universally bare, such that which are cofinal in the wedge rank, and you take the product of this universal sets, and you take this sequence is not in LFR, because for LFR theta is regular. Okay? And I think that's it. Well, this is something that relativizes to LUBGA. So this piece is seen by LUBGA. If you want to work in B, well then, and in B there are large cards. Okay. This piece will not relativize to LUBGA. Okay. Can I prove today the product of this and what I need here is that and you take the product because it's the proof. They prove if a set is unique. Well, this is the problem with LFR. The problem with LFR is that this is model. So if you don't have stealing, the problem is here. There could be sets defined sets of dense sets for Pmax definable here, which are not universally bare in the code, and that for those sets you may not be able to. And so assuming sealing, this is equivalent to say every dense set universally bare in the code is met by this filter. Without sealing, this is stronger and maybe false. Okay. So is I don't know. It's time to, as I written it in the paper, it's probably unnecessarily complicated, but I'm not sure that if I start to cut corners, I will get to a consistent truth. So I will try to give the ideas, and then in case I will go back to the truth in the. So let's do this implication. Okay. They are actually the other one will follow essentially almost automatically by the model companionship stuff. Okay, so what is how would you prove this implication? Well, so you have to find given an existential and without loss of generality, let us suppose that this is a subset of omega 1. I mean, modulo some messaging, we can tweak any parameter appearing in H omega 2 into a subset of omega 1, maintaining that. So if we are able to prove this for the formula with parameter a subset of omega 1, we will be able to prove it for the formula where the parameter is not a subset. And let's use this H.
As long as it's in H omega 2.
Yes, yes. Exists formula exists with A contained in omega 1. We must find universal formula for all x theta c x a. Sorry, apologies, this is not correct. So this is a sentence. I want the formula. So x 1. So no, apologies. It was correct. And let me, for the moment, erase this piece. change the quantified variable, not to have a problem. Such that this theory, let's call this theory T, such that T proves for all y exists x, c, x, y, if and only if theta c, sorry, for all z, theta c, z, y, and this is quantifier 3, and this is quantifier 3.
So now this formula psi can have, well, it has this epsilon delta 0, and then it can have a symbol for non-stationary ideal.
And the symbols for the universal reversal.
Finitely
Finitely many symbols for the. Okay. And so what are we going to do? Well, we so assume the B model star UB plus an S is precipitous. Let gamma be inaccessible. Pick M countable substructure of B gamma. Countable. Let M bar be the collapse. Then M bar is iterable, and for A belonging to let's say let's do it for power set of omega 1. Omega 1 M bar with omega 1 A equal omega 1 of M bar. We have that M bar A is in B max, and if Jm from M bar to H gamma is the anti-collapsing map, Jm of A is equal to some A, which has the same property with omega 1 of LA is equal to omega 1 of B. Okay? And now this Jm will also induce an iteration. I don't have space on the board to write it, but I will cancel on top. And also it will happen that Jm maps restriction to the universal reverse set according to M will map them in the universal reverse set according to B. Okay. And this is a countable piece. And what will be needed in the proof is that if you take this type of map is in L of UB. Okay, so you see this is taking a countable set and mapping it into a countable subset of the universal reverse set. You need that this countable subset of universal reverse set is still coded by a universal reverse set.
Let me just read what you wrote.
Huh?
Let me just read what you wrote.
Yes. Okay. So what happens now? We have here M and here H gamma, and then here we have M bar, and now we can start And here we have the map J, and we can start an iteration on both sides. So what we do here we use the fact that actually let's use that the nest is saturated because it's simpler. You let actually yes. So this group will start with the nest is saturated.
Which J?
Huh?
What is J?
J is this anti-collapsing map.
Oh, so it's making M.
No, sorry. This J is just no, there is no J. So here there is there is the pi m, and here there is the J m. And this is the elementary substructure. So it's just the inclusion. And now you start here to iterate using the Skolemal stuff. So you pass to m1, which is equal to f of m intersection, let's say m intersection omega 1, f belonging to m, which is again a substructure of H gamma. And then you go to m2, which is equal to f of m1 intersection omega 1, f belongs to m1, and then you continue the way and you will get to m omega 1, which is also again a substructure of H gamma. And what happens on this way, you can collapse this or go the other way around. So in this direction you will send, here you follow, you will send this to f g bar m. What is this? F belonging to m bar. F goes from omega 1 of m bar to m bar. And what is this? This is equal to the f belonging to power set of omega 1 in m bar, such that such that m intersection omega 1 belongs to J m of s. Okay? And what is the map? In this direction is standing f g m bar to f of m intersection omega 1. And you can do the same here. Sorry. With this same trick, I mean, the point is that since you have an acid saturated, this GM bar is M bar generic for the non-stationary ideal, for P omega 1 modulo the non-stationary ideal, and so you get that this is a correct version of what can be an M1 in an iteration of M bar, and this is what you set for M bar 1. So M bar 1 now still satisfies that the net is saturated by elementarity, so you can go to M bar 2. What filter you choose to go to M bar 2? You choose the collapse of this one. And on top, you can go on the same because NS omega 1 is saturated. So NS omega 1 is saturated is equivalent to the fact that all countable elementary submodels have that the filter you will have the filter GM equals S belonging to M, such that M intersection omega 1 belongs to S is M generic for P omega 1 mod NS. Okay, so here what happens, I start, NS is saturated will give that this filter is always a generic, an M generic filter for a countable substructure of V. And so I start with a countable substructure, I take the transitive collapse, here I have an M generic filter, I collapse this filter and I get an M bar generic filter, which is generic for the version of P omega 1 mod NS here. I iterate following the rule of P max for allowable iteration on below, and this is the collapse of the hull of M using this operation above. And this can be propagated maintaining the commutativity of this diagram. Okay? So in the end, we will end up with M bar omega 1 and a map, a pair of commuting maps, which are let's say, an isomorphism and an isomorphism of this structure into this structure. Okay? This structure is elementary in H gamma, so if I compose this map with the identity, I get that this structure can be realized into H gamma. Okay? So what happens then? Okay.
Now, before we continue, can I ask them, so, you observe down there that UB sets go to UB sets.
Yes.
What is that?
By elementarity.
Yes, but you are like M is elementary in B gamma, so, I mean.
So V gamma, you go high enough so that the notion of being universally bare is absolute between V gamma and V.
Okay. So, but can you say like where does that get then? I mean,
I think already at H on F3. If you have MM++, otherwise I don't know, it's a reflecting cardinal or.
There has to be somewhere because I was going on the way it's going.
Okay, so what happens now is that you see what happens is that now if I take a sigma, yes,
What are the horizontal arcs?
the horizontal here.
The arcs between M's.
So I have now M1. M1 is an elementary substructure of H gamma. I do the Skolemal of M1 using the same rule, and I continue this way. And the point is that when I do this operation on top, it corresponds to doing the ultra power of the collapse of M1 by the generic filter for the ultra power, which is induced by the collapse of this filter. Okay, and this continues, propagates all along. Okay, so you see now that this one has an elementary map into H gamma. So if essentially it says if I have so let's say that I have a sigma 1 sentence in parameter this A. Well, this sigma 1 sentence is true here if and only if it is true here. Okay? And essentially, since A was moved, what was obtained by moving this small a to big A, it says that if I follow this path and at the end I do this, then I get the sigma 1 sentence here is true if and only if when I get to the evaluation of the parameters here and I follow this path, I get something true in the universe.
Sure, I know that this has to be Captain background. What buzzwords should I know in order to know that this ultra power will commute with just a scalable? It's a question about gap in my background.
Yes.
So what buzzwords should I check to know that this ultra power?
What password?
What buzzwords?
It's just the, if you derive the outer filter from the anti-collapse map, that's generic over.
Okay, sure.
If it was MSC saturated.
Okay. Yeah.
So NST saturated is equivalent to this assertion. Whenever you take a countable submodel of V, this is an M generic filter for the.
The garbage socialization.
Oh, the first one is must be close. But then you need to
The
know.
J socialization of the ultra filter.
Yes, essentially this is So the point is that the anti-collapsing map overlaps with the realization of this in this way.
Yeah, what I was wondering is, to what extent this depends on this particular alpha filter. So what property is this? Because it doesn't.
Well, that's the next point I'm going to.
Okay. I mean, I was trying to understand it because I don't.
So, up to now, this is based on the assumption that the nest is saturated in V. This will work because the nest is saturated in V. Okay.
Just say, if I understood that, so it is only true for this alpha, because I think this picture implies that it's a derived alpha from the embedding.
Yes. Yes. So, but then you have a nice property of Pmax. The nice property of Pmax is that it is homogeneous. So we choose this particular generic filter filter. Now we have start. So this essentially this generic iteration is determining the ultra filter. The ultra filter is determining this generic iteration. So but the forcing is homogeneous. So if I switch the generic iteration to another one, well, that other one is I have star, so that is given by another NS correct iteration of M. Now I just have the piece below, I don't have the piece above. But it is natural to expect that to some extent I will be able to replicate this last step if I move if I change the ultra filter. Okay. So the point is that this last step will be able, we will be able to replicate it essentially just for the fragment of M which is given by HLS. Okay. For that piece, we will have whatever generic iteration of this model we pick. So whatever next correct iteration of this model we pick, we get to the last stage. We look at what is the H omega 2 of this last stage, and that we are able to reflect to realize back in D. Okay? So this is essentially the argument. Well then, okay, so this is a piece of the argument. The second piece of the argument is, okay, so now I have a sort of definition that says if I take this type of models, which are the collapse of countable transitive models of piece of V, large enough piece of V, I switch the generic iteration by which I iterate this model, and I end up in something that is, let's say, faithful to the pi1 and sigma 1 properties of the model that are true in HLF2. Okay? Well, there are two problems. Is that this definition will holds for is given in B. So I have that these models to say that M bar is the collapse of a transitive model of B. I need to talk about B. Okay, so this is the first problem. I have to give a definition of this set of nice models in L of UB. Okay, and the second problem is to have this last one. Okay? But if I can do both stuff, essentially I'm done, because then what I do, I can transfer the sigma 1 statement as follows. So can I erase here? So the sigma 1 statement, so suppose that H omega 2 models exist X, C, X, A. Well, then I pick let B equal M bar belonging iterable, M bar iterable, such that any NS correct iteration of M bar is such that, sorry, I changed the letter. M bar is such that J0 omega 1 of M bar the H omega as its H omega 2 suppose that I can argue that this is universally verb. Then I have my statement here. How do I change it? I change it to for all j is ns correct iteration of m bar belonging to D. Well, here you be in the code, it means, I mean, this is not a subset of the reals, but it is encoded by some subset of the real in absolute manner, so here it's a sloppy way to say it.
Sorry, you say it's HMN to realizable, but
Yes.
it's HMN to equal.
No, I mean, this is a countable structure, you do its omega 1 operation, you get a structure of size F1. Okay? And now you want to realize this structure back.
But if it will be just elementary, then it won't, or it will have a critical point.
Realizable in what will, I mean, it will be elementary. I mean, the point is just the HLF2. So the HLF2, this is structure, this structure will have the correct omega 1. So essentially, it will have its omega 2, which is an ordinal of size F1. And the realization will be the identity on its HLF2, and we'll just move the non-stationary real and the universally perceived. And the realization must, so realizable, actually, what will we need is the sigma 1 manner into B. So not full, I mean, you will get full elementarity, but what will need is needed for the proof is just that it's sigma 1 elementarity. Okay, done for J. J is the next product iteration of M belonging to D with A belonging to M bar. Can you prove that J of J0 M bar omega 1 of this equal to a subset of omega 1, we have that M bar 0 models exist X, B, X, A. So you see, now this is becoming pi 1. Because saying that J is an S-correct iteration is a delta 1 property. Because we have a predicate for the non-stationary real. Okay? Saying that this belongs to D is sigma 0 because we are assuming that this D is universally paired. So this is a sigma 0 property. And now saying this stuff is again delta 1. So essentially now we have a universal quantification and it's almost self-evident that H omega 2 will satisfy this existential statement if and only if it occurs. Well, because this universal quantification is trivial. There's just one such J that does the job. Okay? And we are assuming that when you follow such types of J, the last model is sigma 1 elementary in the true H omega 2. So actually, you don't even need sigma 1. You just need that it is a substructure. Okay? And it realizes this sigma 1 formula because of elementarity of the iteration. So the sigma 1 formula is true in J0 omega 1 of this, but now there is a realization of this sigma 1 formula back, of this structure back to the true H omega 2. So this formula will be true with this parameter and we are done. Okay? So the proof amounts, the proof amounts to this piece. So this has a definition which is made in B, and we have to find an equivalent definition in L of UT. And what now? This essentially will follow, yes, yes. So the point is, yes, you also have to argue that this is dense. So the point is, what happens? This is dense but it's, so on the basis of this definition, you can argue that this is dense, but in V, you can argue that this is dense. Now you have another set which you define in L of V, and you have to ask, so that has a definition that clearly makes it as that definable in L of V, and you have to check that this D contains the extension of the other set, and that the other set is dense. Essentially, I think one will argue that they are not exactly the same, so that you have exact equality.
At the moment, you don't even know it's not empty, right?
Yes. So I think what is about time?
Probably over, I don't know.
Okay.
We started by 1 what?
Recording is for 1 hour exactly.
So it's done.
I know, it's up to you.
I can continue tomorrow.
Okay. If you continue, then you're over. So maybe we.
If somebody else